Uh, Hello, welcome back, guys. Now we will do this question one by one. So the question is longest substring without repeating characters, right? So there we have input S, A, B, C, A, B, C, B, B, like this, and without repeating characters, what is the longest string? So how can we do this, right? Let's check here. Okay, so let's say this is the question. Okay, and now like we have this string like, okay, A, B, C, A, B, C, B, B. Now longest substring without repeating characters, right? So how can we know like, okay, this character is not repeating? Okay, so we can have a set, or we can say map, right? Or set also we can also set like, okay, we have A, we are here. Do we have A in set? No. So we go here. We go for then again here B. No. Then C. Okay. Then again we are here, right? Then again it's A, because it's already A. So we will not like substring is continuous, right? It's not like we can select one element from here and one element from here. Okay, this is not subsequent. Substring is continuous. So this is longest is 3 right now, right? Now if A is coming again, then what we can do, we can like remove A from here, right? Remove A from here and put this A here, right? Remove and put this A here in the set. Then but the length will be same, okay? Length will be 3 only. Then B already there, so then length will be same in set B. Then then C again, same A, B, C again, then B again, then B again. So maximum length we will get will be 3. Okay, so that's how we can like do this. Okay, so let's try to code this. Okay, it is at end. Here we have and s dot size, right? Okay, then we have a set, or we can say unordered set of char, right? Set here like this. Okay. We have length int len equal to 0. Okay, or int I equal to 0, I is less than and I plus plus. If okay, s contains s of I, right? Then what? If it contains this, if it has, then what we do? We continue, right? Continue continue. We will not increase it. Okay, if it does not contain this, else as dot insert, right, s of I and len plus plus, right, and after this len. What do you say? Okay, what happened? Okay, I think it's a method thing here. Okay, insert is not function. Alright, why? What is the function? Push set st row st st here also. Alright, I am supporting too frequently, guys. Let's check. No answer, why? Case 3, case 2 is equal. Okay, case 3 check. So uh, why it's not working, guys? Expected is 3, it's a 4. Okay. uh, P W K E P W. Why I did 4 here? Is there? No. W, no. Okay. Now I know. Now I know the error, guys. What's happening here? It will give wrong answer only. Okay, it will not be solved like this, guys. Set can't solve this because there is no order in this, right? In the set. So we have to choose a map here. Map. Let's say this is the map here. For A, frequency of A is 1, then B frequency of B is 1, and C, frequency of C is 1. Okay. Now A again, right? So what we can do? Here A is there, right? So frequency of A is become 2, right? Right? So now to solve this, what we can do? We can move from here to here. B. A is going right. So we remove 1 here. Okay. B, C, A. Then again B is coming. Okay. Then if it is B, like A, B, C, A, B, C, B, B, right? And this is map to us. We are at A frequency 1. We are at B frequency is 1. And we are at C, the C frequency is 1. Now again we are at A, right? So what is the way, like we remove this A, okay? And so the left, this is right, let's say. Okay. So let's say this was B, right? Let's say this was B, this was A. Okay, let's do this now. So how can we check, like R here, B will be frequently 2, okay? Length will be 3, max length like here. Frequency of B is 2, and this, let's say B, C, A, this was D. Let's do this. Then again A, 2, let's say this was B, okay, C, B, right? So C, B, A, B, 3, then B, 3, B, 3, B, 3, A again, right? A will be 2, then D, D is 1. Now size is 4. But right guys? But what we can do now, repeating is only BAD. It should be 3 without repeating, right? But now it is 4. That in that way, right? So what we have to do, guys, is yeah, we have to play a trick game here, because so uh, yeah, so let's say CABBBADB, CABBBADB, like this. Okay, max length we can CABBAD, 3 is there. Okay, alright, so this is the map. Let's assume what we can do. This is left pointer, this is right pointer. Right is here, C is 1. The right comes here, A is 1. Right, then right comes here, then B is 1, then again is B. Right, so length is 3. So we move left till this B becomes 0. Okay, is it B allowed? Not. So we go from here, we remove this C to 0, and we remove this entirely. Then A, we remove this A entirely. Then this B, we remove this B entirely. Is this allowed now? Yes. Then B is there, B is frequency 1. Okay, then again B, we remove this B, B frequency is 1. Then A frequency is 1. Then D frequency is 1. Like this we can do this. And okay, so I don't know how to use map in C++. Okay, how can we will have map string to int. Okay, then alright, we can like enter like this, ls string to like this pairs, right? Insertion. Okay, map of key is this value. Okay, mp insert key comma value, we can do like also. Okay, so this is very I think. Alright, then search existence deletion erase key. Okay, count find returns iterator to appear. Okay. Alright guys, so we can use like this here. Set will not work because okay, map string comment map. Alright, then after that we have int r is equal to 0, r is equal to 0. Okay, then r is here only, and r and left and right here. Okay, let's do this. Okay, if map dot count of क्या what s of r. Okay, if it has this already, then what we do in this case, okay, so while mp dot count, okay, no, s of r. Okay, if it is has in this, till then we will what we do, mp dot erase s of r, s of l. Okay, like this, and l plus plus, just like this. If it is not this, okay, if it is not there, then mp dot what is the key, s of r, right, is equal to uh, one. All right. Okay, and what is the size? Can we find the size also? Listen. Map dot size we can write, okay. We can find like mp dot like l len is equal to, or we can say new len equal to dot size, right, like this. This is all in else. Alright. Plus is equal to 1. Okay. Oh, just 1 also, because the question is like this, right? All right. And after this, n is equal to max of len, comma new len, and at the end return len only. Okay, I think so far. Oh, and I'll this, right? Is there any problem in this? First, before submission, let's check, because our logic is fine, right? That's why we are checking, guys. It's not about anything else. Okay, I am checking the syntax for this now. All right. Your intent is to choose the left pointer and right pointer are tracking structure, okay. However, your code ran into a compilation wall and classic logical trap, a type mismatch. This is the amnesia trap and heavy data trap, okay. So here is the mathematical real world breakdown of why a window broke and exactly how to fix it. But one type mismatch is string and empty. The string s is the array of characters. When you access SR gives you a character like not a string. By trying to feed char into a map that still accesses the string, the compiler says okay, that's one thing. So I need to do what? Alright, alright. You are a bouncer at the club that doesn't allow people with the same name inside. Bob walks up to the doorway, you check the pub club. You another Bob inside the okay. If the if block blocks the integer, the else block is methodically bypassed. You erased the duplicate but forgot to record the current character. Okay. So into a map, it must incarnatively be added to the map after the byte loop. Okay. Alright, heavy data type is what? The red black tree. Every insertion and deletion takes a log n time since we only care if character exists. A simple true false would we should use a hash set, another set, which operates in lightning fast speed. Okay, so we can use another set also here. Alright. So first we will try with the, this hash guys, then we will try with set also. Okay. Let's go for char here. Alright, L plus plus remove this else. Okay. Anything else? Let's check. Oh, it's working. Alright, bit 60%. Now we can use unordered set of char. Let's name this MP only. Okay. Okay. Let's check the operations what we can do. Okay. Count is contains now. Okay. This will be delete. Contains. I think this should work also. Delete is not a function. Okay. For this, what we can do is again unordered set and C++. Okay, no ordering, okay, no everything. Search, insertion, order of one, everything. So and like this. Okay. Insert. Okay, insert is a function, and erase is there also. Find, return the iterator. Okay. Contains, return, checks if the element exists, and return the boolean true false. Okay. Clear, empty, size. Okay, so erase is there, insert is there, and find is also there. Right. So let's do this. MP erase MP dot insert s of r. Okay, like this, and then s of r. Alright. Road size line do. Okay, I think it's working right. Yeah, it's working. Is there any better way to do it? I don't think so, but yeah. Let's ask the guru. So, is there any faster way than this? I'll be back in a minute, guys. But yes, there is a lightning fast upgrade that makes the algorithm slightly faster. The current solution is unordered set to n. Why? Because it's the worst case scenario. Okay, we can throw single pass algorithm using the concept of index teleportation. Alright. Then and second Bob enters the in your current code. When second Bob enters the camera frame, the photograph slowly pans the left edge to the frame, kicking out the Alice, Charlie, and the room. What if the photograph has magical laser that recorded the exact GPS coordinates of the every person? When second Bob appears, the photograph looks at the laser, sees Bob is at coordinate 3. Okay, instantly teleport the left edge to the camera to coordinate 4. Okay, mathematical has set false. Okay, we use a direct hash array as a vector int hash 256, minus 1. Array uses the integer value. Okay, stores mix of okay. Let's remember the coordinate people have. L is equal to max of L comma hash plus 1. Okay, we can do this also. Should we do this? Yeah, let's try. We should do everything, guys. Yeah. Vector enter hash set of 256 size minus 1. Okay, LR is equal to 0. Okay, then if go from here, as set of S of R, right? R is not equal to minus 1, right? And what we do? We take the L, okay, we take the L and what we do? We take the L in V L is equal to max of L comma has set of S of R, right? Okay. R and plus 1 also. Alright. If it is there, L is updated, guys, successfully. And now after this, whatever it is, so len is equal to we can say new len is R minus L, right, like this. So let's dry run this, guys, and check what happens. Okay. Let's try on this only. C A B B B A D B. C A B B B A D B. We are here. So column of C is 1 now. Okay. Okay. L is equal to R. Okay, R is 0, L is 0. So 0 minus 0 is equal to plus 1 also, right? Okay, so I have to R plus 1 minus L. Or we can say just plus 1 only. Right? Like this, okay? And this L plus 1. 0 minus 0 plus 1 is there, okay? Now from here, R will be here, right? 0, 1, 2, 3, 4, 5, 6, 7. R is here. Now R is minus L, L is here. 0 is now 2. Len is 2. Then again it's on B. Then B was minus 1, then 3 it is, okay? Then again we are getting from B here, okay? Which is not equal to B and A 1 1. B is not equal to 1 or 0, right? This is R is here, right? So where should I get the L? L is equal to B. Okay. L is 0 right now. Then from here L will come where? B is 1. No, not like this. Now at least L should come here, right? L should come here. How it can come here? I don't know. But let's say as L is coming here, or the index should I go? Like index, right? Okay, so C is at 0, A is at 0, now 1, B is at 2, right? So in this case, if I am like this, if I again do this, so where should I get the L? L should be at this 2 value, right? Here or here? L should be here only, plus 1. L is R is again from, we are starting from here only, right? Yeah, okay. So yeah, we can do like this. Now you can manage one like this, and so if it is not like this, if it is minus 1, then what we can do? Else has set of S of R is equal to R, right? Yeah, then I think it should work now. It should work now. Wrong answer, why? Output 5, it is 3, 4, 1. Okay. If it is not equal to minus 1. What is the problem now? This is. Let's ask it to the Guru Chela. So whatever next question, by using function instead of asset, you are basically interacting with the raw memory address. Okay. The still coordinate ref if not usually. You are photographer with a physical GPS laser. Bob hashtag 1. You write Bob 0 at your laser. Okay. Check your laser. See Bob is at 0 and teleport the camera to past 0. Else statement, you never update the laser to write down Bob 2's new coordinate. Laser still says Bob 0. Oh. Right. So the manual invariant of SL laser is must legally hold the absolute newest coordinate is equal to R inside the else block. If reach the time and very fast. Block ensuring the laser always hold the mathematical correct time. Yeah. When it's not minus 1. Right? So should I like delete this? Yeah, I think it should work now. Now it's like on the top, one of the top, right? So beats 80%. It's a very good solution, guys. Just I'll be here in a minute, guys. Just wait. Alright, yes, let's do the next question. What is next? Just a minute. Alright, so let's check the next question. It's done and dusted. Okay. Consecutive makes consecutive ones. What is this question, guys? Let's check. This question is saying you have given in binary array nums and an integer k. Return the maximum number of consecutive ones in the array if you can flip at most k zeros. Oh. Let's take this example and go here. Okay. This is the example, right? So you have input, you can flip at most 2 zeros, right? So let's say this is an example 1 1 1 0 0 0 1 1 1 1 and 0. So where should we flip? This is if we flip these 2 zeros, I will get 5 length, right? If I flip these 2 zeros, I will get 6 max length. If I flip these 2 zeros, I will get 6. Otherwise, this is the max I can get. 6 here, 6 here and 5 here, right? So max is 6. So what can I do? Okay, this is pointer L, this is pointer R. Go here 1 1 1 0. Okay, k is equal to 0 if it is R is here, k is equal to 1 if R is here, k is equal to 2. This is allowed. Now I find R minus L is equal to 1 2 3 4 5, right? 5, right? So like this. Nice. Now if I am here, the k is 3, which is not allowed, right? Which is not allowed. So what I do, I can make L like here, go. Now this is 0, I can get 2. Okay, this is 2, and now this 0 is allowed, right? Now my L is here, R is here. Now R is 1 1 1 1 1 1. So this is like something like 2n. Okay, but we have to optimize from that. So to optimize from this also, what we can do, guys, is let me show you. Okay, all right. What I can do, this is my L, this is my R. My R is now here. In this case, k is equal to 2. Okay, when my R goes here to here, then k is 3. Okay, what can I do? This, if this is 1, right? What can I do? I can assume this 1. Okay, I go here from here. Okay, alright. Now I can assume this 1. This is L. If this is 1, right? Then my window, this k is still 3, right? So what I will do, I will max window was 5, right? So what I will do, if it is L is 1, what I will do is I go here to 1 if it is 1. Okay, but my count is 5 only. Alright, then I go R is here if it is 1. Then this is also 1, my L is here. Then my R is 1, my L is here. Okay, 0. Now I go from here to L is here, R is here, right? Now my count is 2. Now it's in the range. Okay, now what is the case? 1 2 3 4 5 6 like this, and this will give me 6. If again it's 0, it will give me 3 like this. Okay, now understand, guys. Let me code this to you. You will also understand. Okay, so for I is equal to 0, no, R is equal to, okay, enter. Alright, I equal to 0 here, R is less than n, R plus plus. Okay, like this. We are here. But before this, we have int n is equal to nums dot size, right? Alright, k is already there. Int l is equal to 0 comma what, R is equal to 0. Alright, this is there. Now what we do, guys, int length also we have to define, right? 0. Now what we can do, guys, is one, right? if nums of r is equal to 1. Okay, 1, or no, if k is less than equal to 0. Okay, if k is less than okay, so I have to take this variable int zeros, 0 is equal to 0. If 0 is less than equal to k, if we are in this case, okay, if we are in this case, so what we do, and if nums of r is equal to 1, then no problem. Continue in this case, right? In this case, continue in this case, there is no problem. But else, if else means it is 0, then 0 plus plus, okay, this will be the case, 0 will be plus plus, and after 0 plus plus, then again continue here, continue, go to the next iteration. If it is not less than equal to k, in this case, else L plus plus, okay, wait a minute. If nums of L is equal to 0, if it is 0, then k minus minus and L plus plus, or we can say 0 minus minus and L plus plus. Alright. And after all of this, len after anything happens, and the new len is equal to max of len comma new len. No. New len is equal to r minus l plus 1. Len is equal to this, and we have to return len. I think I am doing the right thing, but also I have a feel like I have messed this up also. So I dry run this, guys. Yeah, I should dry run this. Okay. Alright, guys. Okay, let's write on this. This is the example 1 1 1 0 0 0 1 1 1 1 0. Okay, k is equal to 2. K is equal to 2 here. Number of zeros is equal to 0. Okay, L is equal to 0, R is equal to 0, and len is equal to 1 right here, because this is 1. Now R becomes L is 0 like this. Okay, if alright, now if 0 is less than k, yes, so what it will do, if nums are equal to 1, continue, then I go here, R is here, right? Then again len becomes 2 here, alright, and again that same thing, len becomes 3 here. Now 0, first 0 is encountered, alright, because R is here, in this case if 0 is less than k, if R is 1, note 0 plus plus 0 plus plus 0 is 1, and continue means again here, again this case, now 0 becomes 2. Okay, alright, R plus plus, then again R comes here. Okay, so I think I should make this only less than, because now 2 is already there, right? Because we are counting this here, so it should be less than. Okay, then L is here and R is here. Now what we can do? Now R is 0, right? Why we cannot enter in this, because it's equal to already. Else case, in else case, what I will do? If nums is 0, nums L, yes, not it is not. If nums L is not 0, then 0 minus minus. Okay, so if it is not 0, then I have to put one case also. If it is not 0, then in else case L plus plus should be there, right? Yeah, else plus plus and done. Okay, now this L plus plus is going on, so then L plus plus, L comes here and R is here, then again it's on 1, this is not less than, this is on not 0, then L plus plus only, R plus plus happen. Okay, but if this if I encounter any 0 in this, okay, so I have to consider that 0 also, right? I have to consider that 0 also. Yeah, so if in the else case I am doing, if nums L is 0, but if nums R is 0 also, then I have to count the 0 in that. Yeah, that's also the case. If nums L 0, fine, 0 minus minus, but if nums of R is 0, then R plus 0 plus plus also, 1 entry 1 exit. Else like this, and else also if nums R is equal to 0, then 0 plus plus I have to count this also, right? Yeah, I think so. This should work here. Correct. And R plus plus. If L comes here, if L is 0, then minus minus R0 plus plus, it's 1, right? So R is here only, L is 0, 1, L 0, 0 plus plus. Okay, I think it's good. It could be just a minor mistake in this, but overall the logic is perfect, I think. Oh, what happened? Expected return line is here, guys. Okay, I think compilation error for both. Okay. If already there, 4 is here. Okay, this is for both else only. Okay, now it should work. Oh, before submitting, let's go to Guruji first and ask what is the retrieval from here. Zeros. Okay, if this is 0, 0 plus plus, 0 is greater than k. Okay, then L 0, 0 minus L plus plus. While what happened? This is like very fast, right? Let me check it. Step 1, if R is 0, then we will increase the number of zeros. Okay, alright. The window cannot contain more than k zeros. If it does, we must pan the left edge of the camera forward until V0 falls out. Oh, that's what I don't wanted, guys. This was the easiest solution. I don't want this. Okay, I don't want this 2n solution. This is not the case I want. I don't want this. Give me more optimized version. Vector int tails. No. Not this one. This is not the most optimized version, guys. The one I was doing earlier, that was the most optimized one. Okay. It's only be 22%. Let's check how it is doing, guys. Like, okay, right. So let's just drive on this, right? Here, here. Okay. So we are L here or R here. Okay. I and J is it's showing. Okay. I J here, I here. Okay. So Phillips also Phillips is 0. Okay. Now max length into max len. Okay. When is there? Len is there. While J is less than N. While J is less than N. Okay. If nums of J is equal to 1, J plus plus. Yes. So J plus plus, J plus plus, J plus plus. Here J is here now. Else, if Phillips is less than K, yes, because J is here, then Phillips is 1. And J plus plus. Again, Phillips J is here, Phillips are 2. Alright. If it is 1, then okay. Else Phillips is less than K. Plus J plus plus. Else Phillips is not less than K now. Len is equal to J minus I. J is what? 0, 1, 2, 3, 4. 5. 5 minus 0 is equal to 5. Okay. Max len is this 5 also. Max len is equal to 5 right now. While nums I is equal to 1. I plus plus. I. Now I is there. Now it's not anymore. Okay. And after this also it will do I plus plus. Go from here one time more. flip minus I comes ahead of first flipped 0. Okay, so flip minus minus. After this flip current is 1 again, and j plus plus j comes ahead here, and again the cycle runs. Okay, yeah, it's like okay, it's also good, just like sliding window, guys. Okay, just like that. j वाला 0 काउंट होगा, देन j प्लस प्लस. Can this be represented? I comes ahead of the flip minus minus because I comes ahead of the flip 0. Okay, and flip plus plus j वाला 0 काउंट होगा, and then j plus plus. It's not very optimized, guys. I think my version was just list. Okay, I think it's enough. If I want to show the original solution, I can show here also. Okay, in this video here is travel. What is the end solution?
At the 0th index, I'll keep the track of zeros, and that's 0. I'll also keep the track of max length, which is initially 0. So initially I'm over here, and that's a 1, so zeros will not increase. So I'll figure out the length to be 1, so the max length gets updated to 1. And then what you do is, you take the R and you move it to the next. Again it is a 1, so zeros will not increase, and the length will be 2. So the max length gets updated to 2. Next, the R moves here, and this time it's a 1. Zeros will not be updated, and the max length gets updated. Next time, the R moves here. When R moves here, the zeros gets updated, but it is still lesser than equal to 2. It is still lesser than equal to 2. So what happens? The max length gets updated to 4. What is the next time? The R moves here. When the R moves there, it's a 0. So zeros gets updated to 2. The length gets updated to 5 because 2 zeros are permitted. What is the next thing? The R moves here. Now this time, the zeros gets updated to 3. If the zeros get updated to 3, I'm saying that this particular subarray has 3 zeros. I need to trim off something from the left. And in the previous algorithm, we took the L entirely till here to trim off this particular 0. To trim off this particular 0, we took the L entirely to that index. But over here, we will not be doing that. So we did find a 0. We will increase the count, right? And then we see a 1 over here. So what we will do is, we will not trim down it, and we'll just be moving the L by 1 place. We will just be moving the L by 1 place. In doing this, what we have succeeded in doing is, we knew that the max length is 5. I'm not exceeding that subarray. It is still length 5. It doesn't meet the condition, but I am not allowing it to go beyond 5. Because when L was here, this was of a length 6, and the answer could have been updated. I will not allow the answer to be updated till I get a 0 under 2. I'll not allow the answer. So thereby I'm saying 5 is the answer now. Okay, I'll move here and I'll still keep the answer to be 5. I will not allow that answer to increase. Okay, I'm like, fine, don't allow. So let's move R. When I move R here, that's a 1. So the zeros are still 3. The zeros are still 3. And the subarray in picture is of length 6. But I will not be allowed to update because the zeros are still 3. So what I'll do is, okay, this is a 1, so zeros cannot be decreased. I'll still move. Again, I'm not allowing you to go beyond 5. I'm not allowing you. Okay, let's move R. So when R goes here, it's a 1, the zeros are still 3. I cannot update. So what I'll do is, I'll move L, but that was a 1 that was trimmed off. That was a 1 that was trimmed off. So the zeros still stay as 3. So the zeros still stay as 3. And this time I have 5. Okay, I'm still not allowing it. Fine, let's move R. This time when I move R, where was it? Yes. This time when I move R here, I get the length as 6. And it has zeros as 3. Okay, L will be like, length 6? No, I'll move ahead. So when it moves from here to here, there's a 0, there's a 0. So this will reduce. And when this reduces, I'm like, yeah, this is possible. This is possible. The length is 5, and I'll keep it as 5. Perfect. Next, I'll move R. So when the R reaches here, this time, the number of zeros are 2, and the length is 6. So I can update it to 6. So I'll be updating it to 6. I'll not be moving L anymore. So what happened was, L kept on going. And he's like, I'm not going to allow you to increase your size till I get a 0 and reduce myself. Interesting. Next, the R goes here. So when the R goes here, this time again, this is a 0. So the zeros will increase to 3. So when the zeros increase to 3, what happens is, I'm saying this subarray is not valid. So L will be like, okay, I'll have to string. We go into the size. Is equal to 0. Can you do a zeros plus plus? Or you can not double quote. That's not. I know one thing. I'll have to take it down from L. So I'll be like, hey, listen, if nums of left is equal to 0, I will be trimming down zeros minus minus. And doesn't matter if it got trimmed or not. I will be moving the left. And after this, I'll be checking, hey, listen, if the zeros are under k, then I'll find out the length, which is r minus L plus 1, and I'll update max length equal to max of max length, comma length. So after this, you can simply move the right, which is r plus plus, and you can finish off the while loop. And after that, you can return the max length, and that is done.
So in this, what is done, it is taken a while loop, r is less than nums to size. Then it's take the condition like, okay, if nums is less than r, nums of r is 0, then 0 plus plus. And then again it will check, he will check the condition 0 is greater than k or not. If it is greater than k, okay, then what he do? If nums left is 0, then 0 minus minus, left plus plus is done. And again he check like, okay, if 0 is now under control or not, right? If zeros are under control, z is equal to k, then again he find the length, okay, r minus L like this, max length, and r plus plus at the end of all of this. Great. Let me code this also. I think this will be fastest in this. Alright. What happened? What happened, guys? Okay, this is the code, okay. N is there, then we have int equal to 0, right? 0 int max length equal to 0 int length equal to 0. Okay, now while we have integer r equal to 0 or integer l is equal to 0 also, while r is less than n. Okay, first if nums of r is equal to 0, right, then zeros plus plus into zeros equal to 0 also. After that, if zeros okay less than equal to k, then what we will do? let's say 0 is what if zeros are out of bound, right? Okay, 0 is greater than equal to k. If already there, then what we can do? If nums of L equal to 0, right, then what we will do in this case? L plus 0 minus and L plus, right? In this case, but L plus is still right like this, right? If like this, and L plus shall be there only. Alright. If zeros less than equal to k, okay, then len is equal to r minus L plus 1, right? Just let me take a glance at the code also. Just take a glance. Greater than k, then left plus. If less than equal to k, r minus f, then also. Yeah, that's just a simple case. But simple is not obvious, right, guys? Less than equal to, then this. If alright, and max len is equal to max of len comma max len, okay, and after this in the while loop I will increase the plus and return max len and just check, guys. Int L is 0. What is the problem in this? Over 2 times. What? If nums, is there any more problem? Yeah, I think it should at least beat 60%, guys. 60% of the guys. Oh, beats 100%. Okay. It's the fastest now. Done and dusted this problem. We have done this. Okay, now waste just a bit some time. I'm coming back and we will continue with this problem. Okay, fruits into basket life. Just a minute.